Hello everyone. Let's see a next question is about explain the Mohr Coulomb strength envelope. Which question is asked in this question is asked in 2022 and 2024. So what is a Mohr Coulomb strength theory? Coulomb in his investigation observed that one component of a shearing strength called a uh, instinct cohesion is constant for a given soil and it is independent of the applied stress. The shear strength of a soil on a particular plane were expressed by Coulomb as a linear function of the normal stress on the plane as S is equal to C plus sigma 10 phi, which is a Coulomb equations, where C is a shear strength of the soil, S is the shear strength of the soil, C is the apparent cohesion, sigma is a normal stress on a failure plane, and phi is the angle of internal frictions. So C and phi are referenced as the shear strength parameters of the soils. So this is a graph for shear strength and normal stress. Normal stress is on x-axis, shear strength on a y-axis. So if there is a value C, so this is a value C. From there, the normal stress is acting from these points. So C is equal to S is equal to C plus sigma 10 phi, which is a Coulomb strength envelope, and this is a angle of internal frictions. Type of soils based on total strength. On the basis of shear strength, soil can be divided into three categories. So there are three categories of soils now. First is a cohesionless soil, where phi we called as a phi soil. Second is a purely cohesive soil, we call it as a C soils, and cohesion friction soil is a C phi soils. Now this is a graph, plottation of graph for phi soil, C soil, and C phi soil. If there is a phi soil means there is a zero cohesion. If there is a zero cohesion, it means it's a phi soil, which means cohesionless soil. We called it as a cohesionless soil. So phi soil, where is angle is a phi, and we find out the shearing strength is a S is equal to sigma 10 phi. And for second, C is a cohesion soil, a purely cohesive soil. In cohesive soil, there is a cohesion, value of cohesion, so that is some value of cohesion, but there is a no angle of shearing resistance, so S is equal to only C, because this term is get cancelled because of the zero. So value is S is equal to C. For C phi soils, if there is a cohesion is present and also angle of an internal friction, so we has find out the S is equal to C plus sigma 10 phi. Cohesionless soil. These soil are the soil which do not have cohesions. These soils drives the shearing strength from a irregular frictions. These soils are also called frictional soils. Equation for shearing strength is S equal to sigma 10 phi. Example for this kind of sand is this kind of cohesionless soil is a sand and gravels. Second is a purely cohesive soils, which means sea soils. These are the soils which exhibit cohesion, but the angle of shearing resistance phi is equal to 0. These soils are called sea soils. Equation for the shearing strength is S is equal to C. Example, like a saturated clay is a purely cohesive soil. So next is a cohesive frictional soils, C phi soils. These are the composite soils having cohesions and cohesionless both. These are called a C phi soils. Equation for that is S is equal to C plus sigma 10 phi. This equation for the shearing strength, example, clay sand, silty sand, and sandy sand. So these is a Mohr Coulomb strength theory. Thank you.